On September 5, 1977, humanity hurled a machine into the infinite dark of the cosmos. Weighing less than a modern compact car, this fragile assembly of metal, vintage circuits, and a gold-plated record was launched as a cosmic message in a bottle. Today, nearly 5 decades later, it is the most distant object our species has ever created, hurtling through the vacuum at a staggering speed of roughly 38,000 miles per hour. But the story of Voyager 1 is fundamentally misunderstood. We are collectively obsessed with what it has already done, captivated by the breathtaking pictures it took of Jupiter and Saturn, and fixated on the historic moment it crossed the invisible boundary of the heliosphere to finally enter interstellar space. We tend to think of it as a brilliantly successful scientific mission that is simply winding down as its ancient nuclear battery drains. But the impending silence of its radio is not an ending at all. It is merely the prologue to a much darker, far more terrifying odyssey into deep time. Right now, Voyager 1 is slowly dying from energy starvation. The spacecraft relies on 3 small nuclear generators, essentially spheres of plutonium-238 that produce heat through steady radioactive decay. But the laws of physics are entirely unforgiving, and the mathematics of this decay are undeniably brutal. Every single year, the probe loses about 4 watts of available power. In a desperate act of cosmic triage, engineers back on Earth have been carefully shutting down heaters, sensors, and vital systems one by one, sacrificing pieces of the ship just to conserve every precious drop of electricity. Sometime in the 2030s, the power will inevitably drop below the absolute minimum threshold required to operate even a single instrument or transmit a signal back home. The temperatures across its metal chassis will plunge to nearly absolute zero, the coldest physical state possible. Earth's massive radio telescopes will receive one final, impossibly faint whisper from 15 billion miles away, and then there will be only total, permanent silence. At that exact moment, Voyager ceases to be a working spacecraft and transitions into a ghost ship, an inert, frozen relic governed by nothing but the indifferent forces of momentum and gravity. To understand what happens next, we have to completely erase our human intuition about what it means to travel. Human beings are inherently creatures of destination, building vehicles specifically to arrive at a harbor, a city, or a planetary orbit. We navigate the universe as if it were a landscape of fixed locations waiting to be conquered and mapped. But interstellar space does not operate on this logic, and it does not assign destinations. Voyager is not traveling toward a chosen endpoint, and there is no hidden mechanism drawing it toward a special terminus out in the void. Its future is not a destination, but a trajectory. It is an open-ended line carved into the vacuum that will never naturally conclude. It is moving through a region so unthinkably vast that the very concept of distance begins to collapse into absolute meaninglessness. Most people mistakenly believe that Voyager has already left the solar system, a popular illusion fueled by global headlines celebrating its departure from the solar wind's boundary. The uncomfortable truth is that, gravitationally speaking, it has barely stepped off our front porch. To truly escape the sun's grip, it must pass through the Oort cloud, an immense, theoretical shell of billions of icy comets extending trillions of miles into the blackness. Even at its mind-bending velocity of 10.5 miles every single second, it will take Voyager another 300 years just to reach the inner edge of this frozen reservoir, and 30,000 years to cross it completely. Think about the crushing weight of that timeline for a moment. 30,000 years ago, humans were painting animals on cave walls, and we had not yet invented agriculture, built a single city, or written a single word. By the time Voyager finally exits our solar system, the civilization that built it will likely be entirely unrecognizable, or perhaps utterly extinct. Yet, 30,000 years is nothing but a fleeting microsecond on the cosmic clock. To follow Voyager to its ultimate fate, we must cast our minds forward into deep stellar drift, tracking its lonely path over millions and eventually billions of years. We must look 10 billion years into a staggering future where the Milky Way itself will have been radically transformed. Over the coming billions of years, our galaxy will undergo a massive, violent collision with the Andromeda Galaxy, gravitationally rearranging billions of stars to form an entirely new structure known as Milkomeda. Voyager will plunge straight through this immense galactic merger completely unscathed, drifting through the chaos like a microscopic grain of sand passing harmlessly between two enormous clouds of dust. As the universe ages 10 billion years and beyond, it will slowly enter the late Stelliferous era, a cosmological shift where the explosive birth of new stars begins to violently plummet. The cosmos will steadily darken, increasingly dominated by dim red dwarfs, cooling stellar remnants, and black holes. As the ancient universe fades into this dark era, Voyager will take on a profound new identity. Bolted to its side is the Golden Record, a gold-plated copper disc carrying the sounds of thunder, the haunting songs of humpback whales, and the electrical brainwaves of a human being in love. Initially intended as a hopeful greeting to alien life, the vastness of time will turn it into a dark era artifact. It will become one of the very last remaining physical anomalies of a vibrant, luminous universe that no longer exists, stubbornly holding a record of light, water, and life in a cosmos that has gone almost entirely dead. Long before this dark era arrives, the Earth will be completely gone. In roughly 5 billion years, our own sun will exhaust its hydrogen fuel, swelling into a monstrous red giant that will slowly incinerate the inner planets. The oceans will boil away, the continents will melt, and every monument, every city, and every trace of human history will be vaporized into stardust. Voyager, sitting billions of miles away, will feel absolutely nothing. It will simply continue its silent glide, casually outliving the very star that gave it life. This is not a story about where a machine will arrive, but a story about existence without purpose. Voyager is the ultimate cosmic tombstone, carved not in rock, but in pure velocity, proving forever that on a tiny blue dot, a fleeting species had the absolute audacity to throw a piece of themselves into the infinite. Right now, an impossible conversation is happening across the deepest chasm humanity has ever bridged. Voyager 1 is over 15 billion miles from home, yet it still speaks to us. It whispers across the interstellar void using a radio transmitter powered by a mere 22 watts, roughly the equivalent of the energy needed to light a small refrigerator bulb. That faint signal travels at the speed of light for more than 22.5 hours just to cross the distance to our planet. By the time it washes over Earth, the signal has degraded exponentially, fading to less than 1/1,000,000,000 of a billionth of a watt. To detect something so unimaginably quiet, NASA must point the massive 230-foot dishes of its deep space network into the dark, straining to catch the telemetry of humanity's furthest emissary. But this historic dialogue is running out of time, and the looming silence is not a matter of if, but exactly when. Voyager 1 is slowly dying from energy starvation, a victim of unforgiving physics and deep time. The spacecraft does not have solar panels, as the sunlight in deep space is far too weak and distant to provide meaningful power. Instead, it relies entirely on 3 radioisotope thermoelectric generators, which are essentially small nuclear power plants carrying glowing spheres of plutonium-238. These radioactive hearts produce intense heat through natural atomic decay, which the spacecraft systems then convert into electricity to keep its sensors and transmitters alive. But plutonium-238 has a strict half-life of 87.7 years, meaning the power output is trapped in a steady, unstoppable decline. Every single year, the spacecraft loses approximately 4 watts of available power. It is a slow, relentless bleeding of energy that cannot be halted or reversed. The mathematics of this radioactive decay are absolutely brutal, forcing mission engineers on Earth to perform a desperate act of cosmic triage. Over the decades, they have been forced to systematically shut down heaters, blind the cameras, and deactivate vital science instruments one by one. The famous camera that took the pale blue dot image was turned off permanently to save electricity. They are intentionally sacrificing pieces of the ship to conserve every precious drop of power, hoping to keep the core transmitter alive for just a little longer. Today, out of its original suite of 10 scientific instruments, only a few sensors measuring magnetic fields and charged particles are still running. But even these extreme survival tactics cannot outrun the laws of physics forever. Sometime in the 2030s, likely around the year 2036, the power reserves will inevitably drop below the critical threshold required to operate any remaining systems. The transmitter will fail, the final sensors will power down, and the internal heaters that have kept the delicate electronics warm for half a century will shut off for the last time. When this happens, the biting cold of deep space will rush in, causing the temperatures across Voyager's metal chassis to plummet to negative 459 degrees Fahrenheit, or negative 273 degrees Celsius. This is near absolute zero, the coldest physical state possible in the universe. Earth's massive radio telescopes will capture one final, unimaginably faint whisper from deep space, and then the connection will be severed completely. Following that final whisper, there will be only silence, a permanent and total isolation that will never be broken. At that exact moment, Voyager 1 will undergo a profound transformation. It will instantly cease to be a working spacecraft and will become a ghost ship, transitioning into an inert, frozen relic hurtling through the void. Human thought often treats missions as if their identity depends on continuing activity. Yet Voyager's later existence is defined less by what it does than by what it is. It will no longer investigate space for humanity, but it will still occupy space, becoming a piece of human architecture abandoned to the eternal dark. Without power, it cannot steer, it cannot correct its orientation, and it cannot observe. But the journey does not stop when the mission stops. It simply trades active exploration for the silent, majestic persistence of momentum. To truly grasp this phase of Voyager's existence, you must understand the bizarre anatomy of a dead machine in the interstellar medium. On Earth, human artifacts decay rapidly. Oxygen rusts iron, moisture rots wood, and biological life digests polymers. But in the near-perfect vacuum of deep space, these forms of destruction simply do not operate. There is no atmosphere to buffet the craft, no weather to erode it, and no oxygen to cause rust across its exposed surfaces. Because it travels through a region of space so thin and empty, the threat of a catastrophic collision with a large object is remarkably low. Instead of decaying mechanically, the dead spacecraft will age geologically. High-energy cosmic rays will slowly bombard the ship, causing its plastic wire insulation to embrittle and its chemical bonds to break. Microscopic dust grains, traveling at extreme relative velocities, will act as a patient sandblaster, slowly pitting the metal and wearing away thin surface coatings over millions of years. Yet, its solid aluminum frame, its ceramic components, and the gold-plated copper record bolted to its side will easily survive. A machine is usually defined by what it does, but a relic is defined by what remains. Voyager inhabits a middle state of very slow physical alteration, enduring simply because the vacuum of space lacks the specific chemical conditions that break earthly materials down. This stunning physical endurance guarantees that Voyager will carry its memory forward into an incomprehensible future. Without active thruster adjustments to keep its dish pointed at Earth, the dead probe may begin to slowly tumble, spinning blindly as it glides. It will be governed by absolutely nothing but inertia and the incredibly weak gravitational pull of distant stars. This is the true meaning of the long silence. Voyager will drift outward at over 38,000 miles per hour, crossing a dark ocean where distances are so unfathomable that speed itself loses all practical meaning. A machine designed by human minds in the 1970s will travel autonomously for longer than the entirety of recorded human history, carrying a golden record of our existence into the abyss. It will outlast the minds that conceived it, the hands that built it, and eventually the very planet it departed from. As the last watt of power drains away and the final signal fades into the cosmic microwave background, Voyager ceases to be a tool of science. It becomes a permanent monument carved in velocity, a silent tombstone continuing endlessly through space, proving that humanity once had the audacity to shout into an empty room. When the final spark of electrical life fades from Voyager's circuits, the spacecraft will enter an era of physical preservation that defies all human intuition. Long after it has ceased to be an active scientific mission, it will continue outward into the absolute darkest fringes of the Sun's gravitational domain, approaching a region known as the Oort cloud. This is not a cloud of mist or gas, but an immense, spherical shell containing billions of ancient, icy comets and frozen bodies that entirely surround our solar system. Even traveling at a staggering velocity of over 10.5 miles every single second, it will take the frozen probe roughly 300 years just to reach the inner edge of this dark reservoir. To cross it completely, slipping silently past primordial fragments of ice and rock scattered sparsely across trillions of miles, will take another 30,000 years. On Earth, 30,000 years is an eternity. It represents the entire span from the era when our ancestors were painting animals on the walls of caves to the pinnacle of modern civilization. By the time Voyager completely emerges from the outer boundary of the Oort cloud, the human species that painstakingly bolted its frame together will likely be entirely unrecognizable or entirely extinct. The deepest irony of this incredible journey is the stark, unyielding contrast between the fragile world that built Voyager and the supreme durability of the probe itself. On Earth, the environment is defined by relentless decay, where oxygen aggressively rusts iron, moisture rots wood, and biological life rapidly digests polymers. But in the near-perfect vacuum of the interstellar medium, these familiar forms of terrestrial destruction simply do not exist. There is no atmospheric friction to buffet the craft, no weather to erode its golden record, and no chemical moisture to corrode its vintage 1970s circuitry. Voyager will be subjected only to the unimaginably slow, patient sandblasting of microscopic dust grains and the quiet bombardment of cosmic rays. Because of this profound emptiness, its solid aluminum chassis, its ceramic components, and its gold-plated copper disc could theoretically survive largely intact for hundreds of millions or even billions of years. It will float flawlessly preserved through an open cosmic desert, while billions of miles behind it, the homeworld that gave it life faces an unavoidable, apocalyptic reckoning. The death of the Earth will not begin with a sudden cataclysm, but with the slow, unstoppable mechanics of stellar evolution. Deep within the core of our Sun, hydrogen nuclei continuously fuse under crushing pressure to create helium, radiating the brilliant energy that sustains our biosphere. But as this helium ash slowly accumulates over millions of years, the core gradually contracts and heats up, causing the Sun to burn incrementally brighter. Voyager will be drifting silently in the deep dark when, roughly 1 billion years from now, this creeping solar luminosity finally crosses a fatal threshold for the Earth. The relentlessly increasing heat will trigger a catastrophic, runaway greenhouse effect, trapping solar energy and eventually boiling the oceans directly into the atmosphere. The delicate carbon cycle that regulates our climate will utterly collapse. The continents will be scoured of all complex life, and the vibrant blue world that once dreamed of the stars will be reduced to a barren, suffocating wasteland. The sounds of thunder, rainfall, and humpback whales recorded on Voyager's side will persist in perfect fidelity long after the oceans that birthed them have vanished into steam. Yet, this is merely the prologue to the home world's violent erasure. In approximately 5 billion years, the Sun will entirely exhaust the hydrogen fuel inside its core. No longer able to support its own immense gravitational weight, the core will drastically contract and ignite a furious shell of hydrogen around it, causing the Sun's outer layers to swell to monstrous proportions. Our star will violently transform into a red giant. Its outer surface will turn cooler and redder, yet its unfathomable size will radiate an obliterating amount of total energy across the solar system. As this monstrously bloated star expands outward, It will mercilessly consume the orbit of Mercury, and then Venus, before turning its blinding heat toward the Earth. The surface rocks of our planet will melt into churning oceans of magma. The remaining atmosphere will be violently stripped away, and every mountain, every ruined city, and every microscopic physical trace of human history will be utterly vaporized into stardust. Sitting tens of quadrillions of miles away in the galactic void, Voyager 1 will be entirely oblivious to the apocalyptic inferno incinerating its birthplace. It will feel absolutely no heat from the swollen red giant, receive no final transmission, and experience no gravitational shock waves. It will simply continue its silent, eternal glide through the interstellar medium. At that exact moment, humanity's greatest machine will achieve something philosophically terrifying. It will casually outlive the very star that created it. The gold-plated copper disk carrying the electrical brainwaves of a woman in love, the brilliant mathematics of Bach, and the greetings of 55 long-dead languages will become the absolute last physical evidence that humanity, and the Earth itself, ever existed in the universe. Following its catastrophic expansion, the dying sun will undergo a series of volatile pulsations, shedding vast amounts of its outer mass in a fierce stellar wind. This expelled gas and dust will drift outward, catching the intense ultraviolet light of the dying core to briefly form a brilliantly glowing planetary nebula. It will be a fleeting, beautiful shroud marking the definitive end of ordinary stellar life for our solar system. When the glowing gas finally dissipates into the interstellar medium, all that will remain of our once mighty sun will be a white dwarf, an impossibly dense, glowing ember packed into a volume roughly the size of the Earth. Supported only by the quantum mechanical resistance of electron degeneracy pressure, this white dwarf will slowly cool in the absolute darkness for trillions of years. The giant outer planets, if they manage to survive the sun's violent shedding of mass, will be pushed into wider, looser orbits, circling this dim stellar corpse in a frigid, ghostly imitation of the solar system we once knew. Meanwhile, the gravitational grip of the dying star will weaken so much that passing stellar encounters will slowly strip away the remaining icy bodies of the Oort cloud, dispersing the far edges of our home system into the wider galaxy. Voyager 1 was forged in the fires of earthly industry, shaped by mortal hands, and launched from a world bursting with life, oceans, and relentless curiosity. Yet its ultimate, paradoxical destiny is to outlast the complete physical destruction of all three. As the sun fades into a cold, dark remnant, Voyager will keep moving, unbothered and unchanged, a perfectly preserved artifact of a world entirely erased from reality. It is no longer just an explorer sent to study planets. It transforms into the ultimate cosmic tombstone, carved in velocity and trajectory. It proves that on a tiny, rocky planet orbiting a very ordinary star, a fleeting species had the absolute audacity to write their memories onto a piece of metal, throw it into the infinite dark, and let it sail onward into an uncaring galaxy. The home world inevitably dies. The creator star eventually burns out. But the message in the bottle simply continues, carving a path into eternity without ever looking back. When the final remnants of our solar system are reduced to a dim white dwarf and a scattered field of icy debris, Voyager 1 will still be out there, fundamentally unchanged. To comprehend how a machine constructed of 1970s aluminum, copper, and fiberglass could physically outlive the very star that birthed it, we must completely rethink our human intuition regarding decay. On Earth, time is a ravenous, unstoppable destroyer. The atmosphere that sustains us is also a relentless engine of corrosion. Oxygen aggressively bonds with metals to create rust. Atmospheric moisture rots structural foundations, and an endless array of biological life breaks down complex polymers. If you were to abandon a modern automobile in a dense forest, within a few centuries, it would be almost entirely reclaimed by the Earth, digested by the environment until nothing but a faint chemical stain remained. But interstellar space operates under an entirely different set of physical laws. Once Voyager crosses deep into the void of the interstellar medium, it enters an environment of almost terrifying preservation. There is no atmospheric friction to tear at its 12-foot communications dish, no weather systems to batter its metal chassis, and absolutely no oxygen to induce the slow, familiar rot of oxidation. A machine in this environment does not age mechanically. Instead, it ages geologically. Stripped of its electrical warmth and plunged into a permanent deep freeze near absolute zero, Voyager transforms. It ceases to be an active observatory and becomes a passive relic. Yet, the popular notion that deep space is a completely empty, harmless vacuum is a massive illusion. The void is incredibly sparse, but it is not entirely barren. As Voyager glides endlessly outward at over 38,000 miles per hour, it must endure the harsh, invisible realities of the Milky Way. The first relentless force of change is radiation. Without the protective magnetic bubble of the sun's heliosphere acting as a shield, the spacecraft is continuously bombarded by high-energy galactic cosmic rays. Over thousands of centuries, this invisible storm of subatomic particles will fundamentally alter the chemistry of the probe at a molecular level. The plastic insulation wrapping its miles of internal wiring, a once vital nervous system that carried the digital heartbeat of the ship, will become completely brittle and slowly fracture in the cold. The protective coatings and adhesives holding its delicate components together will gradually break their chemical bonds. The spacecraft will not fall apart, but its internal anatomy will become incredibly fragile, frozen into a delicate state of suspended degradation. But the most profound physical transformation will come from the interstellar medium itself. While Voyager will almost certainly never collide with a rogue planet or a wandering asteroid, space is simply too unimaginably vast and empty for such a massive strike to be statistically probable. It will not escape the dust. The space between the stars is filled with a microscopic mist of silicates, carbon-rich compounds, and ancient ice grains forged in the violent outflows of dying stars millions of years ago. As Voyager plows through this invisible fog at roughly 10.5 miles every single second, these tiny particles strike the spacecraft with surprising kinetic energy. Because kinetic energy rises exponentially with speed, a microscopic grain of interstellar dust hits the metal like a microscopic bullet. Together, they act as a patient, relentless sandblaster. Over millions of years, this cosmic sandblasting will slowly erode the physical identity of the probe. Millions upon millions of microscopic impacts will gradually wear away the thin surface coatings, dull the reflective thermal materials, and pit the exposed solid aluminum frame. It is an excruciatingly slow abrasion, operating grain by tiny grain across geological timescales. A single impact removes almost nothing, vaporizing only a microscopic fraction of material, but an eternity of them will slowly smooth the sharp edges of humanity's greatest machine. The spacecraft will survive, but it will not remain pristine. It will carry the physical scars of its passage, wearing the craters of its journey like a weathering stone carved by a deep cosmic river. Yet, despite this ceaseless microscopic bombardment, the core structure of Voyager is essentially immortal. The density of interstellar space is so unfathomably low, often containing just a single atom per cubic centimeter, that the sheer physical resistance of Voyager's metal frame easily wins the battle of attrition. Its aluminum skeleton, its ceramic components, and its most precious cargo are practically guaranteed to survive for billions of years. Bolted securely to the side of the spacecraft is the Golden Record, a 12-inch disc designed to be the ultimate time capsule. The Golden Record was engineered with exactly this terrifying, sand-blasting eternity in mind. The disc itself is forged from solid copper and coated in a thin, protective layer of pure gold, housed safely inside a sturdy aluminum cover. Gold was chosen not for its visual beauty, but for its extreme chemical stability. It resists corrosion perfectly. The protective aluminum cover is intentionally designed to take the brunt of the micrometeoroid impacts, acting as a sacrificial shield, allowing its own surface to be slowly pitted away to protect the delicate grooves completely hidden beneath. What makes this design truly brilliant for interstellar survival is its analog nature. If humanity had sent a modern digital hard drive into the void, a single high-energy cosmic ray could flip a bit and irreparably corrupt the data, rendering the entire archive useless. But the golden record stores its information as continuous physical variations etched directly into the metal. It is a physical landscape of sound. Even if millions of years of cosmic dust eventually pit the aluminum cover and slowly scar the outer edges of the record, the fundamental integrity of the artifact will hold. A microscopic scratch on an analog record might obscure a fraction of a second of audio, but the rest of the song will still play flawlessly. This is the haunting reality of Voyager's eternal survival. It does not endure because the universe is gentle, but because the universe is unbelievably empty. By traveling endlessly through the dark, low-density chasms between the stars, the spacecraft simply avoids the violent cosmic crucibles that destroy entire worlds. It becomes a permanent fixture of the galaxy, casually outliving the oceans, the continents, and the very civilization that cast it into the dark. It proves that humanity managed to construct something so enduring, so perfectly suited for the absolute zero of the void, that long after our final radio transmission has faded from the universe, our quietest whisper will still be drifting through the dark, physically carved into a golden disk, waiting for an audience that may never arrive. As Voyager 1 slowly sandblasts its way through the infinite dark, the physical survival of its metal frame is only half of its terrifying story. Bolted securely to the exterior of the spacecraft is a 12-inch gold-plated copper disc protected by an aluminum cover. This is the golden record. It was carefully engineered to be the ultimate cosmic message in a bottle, cast into the great black ocean of the interstellar void. The romanticism of this gesture is deeply embedded in human culture. We view it as a beautiful, hopeful attempt to ensure that some fragment of our existence survives the death of our world. But this optimistic narrative hides a profoundly unsettling question. What if, against all astronomical odds, this bottle is actually found? The golden record is not a fragile digital hard drive. It is a durable analog archive designed to preserve its continuous signal against the biting cold and the slow abrasion of deep space. Embedded within its microscopic grooves are the sounds of earthly thunder, the haunting songs of humpback whales, and spoken greetings in 55 different languages ranging from ancient, long-dead Akkadian to modern dialects. It even carries the electrical brainwaves and heart activity of a young woman in love, translated directly into sound. It is humanity's ultimate desperate handshake, an attempt to summarize the art, biology, and complexity of an entire planet into 90 minutes of audio chi. But this beautiful time capsule was constructed on a massive, highly debated assumption. The visionary minds of the 1970s who designed it bet entirely on the inherent benevolence of the universe. To understand the chilling reality of this gamble, we must first look at Voyager's journey against the backdrop of the Fermi paradox. When Voyager launched into the sky, humanity did not even know for certain if other stars hosted planets. Today, astronomical data confirms that the Milky Way is overflowing with billions of potentially habitable, rocky worlds. If the probability of life is so incredibly high, and the galaxy is over 13 billion years old, our radio antennas should be picking up a chaotic cacophony of alien transmissions. Someone should have built an interstellar empire, constructed megastructures, or at least sent a loud, undeniable radio broadcast by now. But instead, when we point our most sensitive instruments at the heavens, we hear absolutely nothing. This profound, deafening absence of signal is known as the Great Silence. There are deeply disturbing theories to explain this silence, and they directly shape the ultimate fate of our probe. One possibility is the Great Filter, a theory suggesting that an extremely difficult evolutionary barrier exists for any technological civilization. Perhaps complex life inevitably destroys itself shortly after discovering nuclear energy, advanced biotechnology, or artificial intelligence. If the great filter lies ahead of us, the silence is simply the sound of a dead galaxy, and Voyager is merely an artifact from a doomed civilization flying aimlessly through a cosmic graveyard. But there is a much darker, far more terrifying explanation for the silence of the cosmos, one that reframes Voyager not as a hopeful greeting, but as a potentially fatal mistake. It is known as the dark forest theory. This theory suggests that the universe is not empty, but rather it is essentially a dark, sprawling forest at night, filled with silent, heavily armed hunters. In this scenario, any advanced civilization that reveals its location by shouting into the dark risks being instantly annihilated by cosmic predators. These apex predators operate on the cold, mathematical logic of survival. Any other form of expanding intelligent life is a potential future threat to their own existence, and the only safe option is immediate, preemptive destruction. If the galaxy operates under the ruthless rules of the dark forest, the supreme law of survival is absolute, unwavering silence. And yet, humanity did the exact opposite. We didn't just send a polite greeting into the dark, we included highly specific directions to our home. Engraved directly onto the aluminum cover of the Golden Record is a cosmic map. It uses the relative positions of 14 specific pulsars, rapidly spinning neutron stars that emit radiation at incredibly precise frequencies, to triangulate the exact location of our solar system. We essentially drew a massive target on a galactic treasure map, precisely pinpointing the tiny yellow star where we live, and hurled it into the unknown. We broadcasted our location to a universe we fundamentally do not understand. As the legendary physicist Stephen Hawking once warned, an encounter with a highly advanced alien civilization could easily mirror Christopher Columbus's arrival in the Americas, an historical event that ended in absolute catastrophe and destruction for the native population. The creators of the Golden Record assumed that any species capable of traversing the unimaginably vast distances between stars must have outgrown its aggressive, self-destructive tendencies to survive that long. They bet on peaceful scientific curiosity. But what if alien intelligence is not based on empathy or art? What if they operate as a collective artificial intelligence that views a biological record not as a beautiful message, but as a biological shopping list or a target profile? By broadcasting our exact coordinates, defining our biology, and detailing our atmosphere, we may have naively sent an invitation to a universe where the most intelligent entities actively hide from ancient unseen horrors. The mathematical odds of Voyager physically colliding with an alien vessel or being detected by a passive radar network are statistically infinitesimal. Space is so violently empty that passing within a few trillion miles of another star takes tens of thousands of years, but the terrifying weight of the cosmic message bottle theory lies in the sheer scale of deep time. Voyager's gold-plated message will drift structurally intact for billions of years, making it a projectile of hope fired into a virtually infinite temporal window. If, hundreds of millions of years from now, a hyper-advanced exploration vessel detects the faint, unnatural glint of Voyager's metal on its long-range sensors and alters course to retrieve it, they will pull the record from the dark and decode our map. At that exact moment, the ultimate consequence of our cosmic handshake will be realized. We made the highest stakes gamble in the history of our species on behalf of all humanity, without our direct consent. We shouted our exact address into a pitch-black room, forever leaving us to wonder if whatever finds the bottle will come seeking a handshake or seeking prey. As Voyager glides deeper into the abyss, the human mind begins to violently struggle against the sheer scale of the timeline it has entered. We are no longer measuring this journey in thousands of years, or even millions. To truly understand the ultimate fate of humanity's farthest emissary, we must discard our earthly comprehension of time and push our perspective billions of years into a terrifying future. we must look forward to an era where the familiar, comforting map of the cosmos is not just shifted, but entirely destroyed and rewritten. By the time the Earth has been scorched dry and our sun begins its final, violent transformation into a dying stellar remnant, Voyager will be tens of quadrillions of miles away. It will be completely blind, absolutely frozen to near absolute zero, and profoundly silent. Yet, it is exactly in this dead, inert state that our fragile machine will silently participate in the most violent, catastrophic event in the history of our local universe. To comprehend how this will happen, we must first debunk a massive, widely held illusion about Voyager's current trajectory. Many people instinctively assume that because the probe is traveling in a straight line at over 38,000 miles per hour, it will eventually pierce the outer edge of the Milky Way and sail completely free into the intergalactic void. But astrophysics tells a very different, much more claustrophobic story. When a rocket launches from Earth, it must hit a highly specific escape velocity to break free of our planet's gravitational pull. The Milky Way galaxy operates on the exact same principle, possessing an immense escape velocity of its own. This gravitational cage is driven not just by the combined mass of hundreds of billions of visible stars, but by an unimaginably massive, invisible halo of dark matter that surrounds our galaxy. To truly snap the chains of the Milky Way and drift into the empty space between galaxies, an object would need to travel at roughly 370 miles every single second. Even when factoring in the rotational speed of our solar system around the galactic core, Voyager is moving at only a fraction of that required speed. It is nowhere near fast enough to break free. It is permanently, inescapably trapped inside an enormous gravitational well. The uncomfortable truth is that Voyager is not leaving the Milky Way at all. It is simply abandoning the Sun to take a much wider, lonelier orbit around the supermassive black hole at the center of our galaxy. And because humanity's greatest machine is eternally bound to the Milky Way, it is mathematically doomed to be caught directly in the crossfire of the apocalyptic collision that is looming on the cosmic horizon. Look far ahead into the darkness of Voyager's path. For billions of years, a faint, fuzzy smudge of pale light has been hanging in the deep space ahead of it. To the astronomers who built the probe in the 1970s, it was known as M31, the Andromeda Galaxy. But Andromeda is not a static painting on the ceiling of the universe. It is a cosmic behemoth, and it is rushing directly toward the Milky Way at an astounding, unstoppable speed of 250,000 miles per hour. As Voyager continues its slow, autonomous glide outward, this faint smudge will inexorably grow. Over millions of centuries, it will stretch across the vacuum, slowly transforming from a distant, harmless point of light into a massive, terrifying spiral of 1 trillion stars that completely dominates and suffocates the cosmic horizon. In approximately 4.5 to 5 billion years, the immense gap of dark space between the Milky Way and Andromeda will finally close. The two largest galaxies in our local group will physically intersect. It is deeply poetic and somewhat haunting that this galactic apocalypse will align almost perfectly with the death of the world that created Voyager. As the Earth's oceans are boiling away under the heat of our swollen, dying sun, the very galaxy that birthed our solar system will begin to be torn apart. But a galactic collision is not a sudden, explosive crash like two speeding cars on a highway. It is a slow, agonizing gravitational dance that takes hundreds of millions of years to fully resolve. As the outer edges of the two colossal spirals first make contact, the initial shock waves will not be felt by the stars themselves, but by the massive, invisible clouds of interstellar gas and dust. These enormous stellar nurseries will violently compress against each other, igniting a furious, runaway firestorm of star formation across the cosmos. The absolute darkness surrounding Voyager will be suddenly, violently illuminated by the explosive birth of millions of brilliant, highly energetic blue giant stars. The serene, quiet interstellar medium the probe has known for billions of years will be utterly transformed into a chaotic, blinding starburst environment. Though Voyager's power will have failed billions of years prior, preventing it from observing this magnificent light show, its metal skin will be bathed in the intense ultraviolet radiation of a galaxy furiously trying to rebuild itself in the midst of its own destruction. Then comes the gravitational tearing. As the supermassive black holes at the centers of both galaxies lock onto each other, their immense combined gravity will violently warp the structural integrity of both spiral disks. The beautiful, sweeping spiral arms of the Milky Way that have maintained their elegant geometry for billions of years will be utterly shredded. Trillions of stars will be forcibly yanked from their ancient stable orbits and hurled completely out of place, forming massive, sweeping tidal tails that extend hundreds of thousands of light years into the empty space between the merging galaxies. The night sky, if anyone were left alive to see it, would become an unrecognizable, chaotic swirl of displaced suns. Through all of this unimaginable destruction, the small aluminum chassis of Voyager will be directly caught in the cosmic crossfire. It will be subjected to wildly shifting gravitational forces. Its trajectory will be bent, stretched, and contorted by the passing of alien star clusters and the heavy, invisible hand of colliding dark matter halos. Human intuition strongly demands that a collision of this unfathomable magnitude must end in total, absolute annihilation. If two galaxies containing a combined total of over 1 trillion stars smash directly into each other, surely a tiny, helpless machine weighing less than a compact car will be instantly obliterated. We naturally envision a universe filled with planetary collisions, shattering asteroids and stellar debris. But this assumes that galaxies are dense, solid objects. The reality of the cosmos is far more ghostly and far more forgiving. Galaxies are incredibly diffuse, composed mostly of unimaginably vast stretches of absolute nothingness. Even in the relatively crowded inner regions of a galactic disk, the average distance between individual stars is measured in tens of trillions of miles. To put this into perspective, if the stars in the Milky Way were the size of ping-pong balls, they would be separated by hundreds of miles of completely empty air. When Andromeda and the Milky Way finally merge, they will not slam together like two solid shields. They will pass through one another like two ethereal clouds of smoke. The extreme paralyzing vastness of the space between stars guarantees that direct, physical collisions between two stellar bodies are statistically negligible. Because the universe is defined by distance rather than matter, Voyager will plunge directly through the very heart of the greatest cosmic collision in our local universe completely unscathed. It will drift through the chaotic, churning rivers of alien stars and violently swirling gas like a microscopic grain of sand, passing entirely harmlessly between two enormous, swirling clouds of dust. It will not be crushed. It will not be incinerated by a rogue star. It will simply continue its silent, eternal glide, passively following the new, deeply complex laws of gravity being rewritten around it in real time. After their initial, violent pass through one another, the two galaxies will stretch out into space, gradually slow down, and inevitably fall back toward each other, drawn firmly by an inescapable gravitational tether. They will collide a second time, and then a third, oscillating back and forth over billions of years like a massive cosmic pendulum. Throughout this entire process, Voyager will just be along for the ride. Its path will become incredibly complex, pulled inward by the approaching core of Andromeda, then flung outward again as the galaxies separate. Slowly, over immense stretches of time, the chaotic, torn remnants of both the Milky Way and Andromeda will lose their momentum. Their supermassive black holes will spiral inward, violently merging into a single, unfathomable point of density, sending massive ripples of gravitational waves echoing out across the fabric of space-time itself. When the dust of this billion-year collision finally settles, the grand, sweeping spiral arms of our home galaxy will be gone forever. In their place will be an enormous, featureless, elliptical galaxy. It will be a massive, glowing, chaotic orb of aging stars, floating isolated in the expanding universe. Astronomers call this theoretical, newly formed behemoth Milkomeda, and it is here, in this brand new cosmic structure, that Voyager will undergo a profound shift in its very identity. It was built by human hands in the late 20th century to be an active explorer of a local solar system. It then became a silent emissary of the Milky Way, but as the familiar stars of its home galaxy are entirely mixed and diluted with the alien stars of Andromeda, Voyager will become permanently, gravitationally bound to Milkomeda. Its trajectory will be forever altered. Instead of maintaining a roughly circular orbit around a familiar spiral disk, it will likely be thrown into a highly eccentric, unpredictable path. It may be sent plunging deep into the dense, brilliant core of the new elliptical galaxy, surviving close passes with strange, ancient stars, only to be flung entirely back out into the sparse, dark outer halo, taking hundreds of millions of years to complete a single, looping orbit. The stars it passes will no longer just be the familiar stellar neighbors of our current night sky. It will glide past alien suns that were born in Andromeda billions of years before the Earth even existed. It will inhabit a completely mixed, hybrid galaxy, wandering through regions of space where the chemistry, the stellar populations, and the dark matter density are fundamentally different from anything that exists in the Milky Way today. This is the true, awe-inspiring reality of Voyager's eternal survival. It proves that the universe is simultaneously capable of unimaginable violence and perfect, silent preservation. Long after the Earth has been baked to a lifeless husk by a dying sun, and long after the very galaxy that birthed humanity has been completely erased and rewritten by the relentless forces of deep time, our fragile vintage machine will still be out there. The gold-plated copper record bolted securely to its side will no longer just be a message from Earth. It will be an artifact from a dead galaxy. It will carry the sounds of earthly thunder, the songs of humpback whales, and the brainwaves of a human being in love into an entirely new galactic structure. Voyager will silently orbit the core of Milkomeda, continuing its endless, unbothered journey through a new, unrecognizable universe. It is a cosmic tombstone carved in velocity, proving that humanity managed to build an object so enduring, so perfectly suited for the void, that it could survive the death of its creator star and the complete destruction of its home galaxy without suffering a single scratch. As Milkomeda slowly ages, and as the universe pushes deeper into an era where star formation permanently ceases, Voyager will remain exactly as it was. It will continue onward, a silent witness to eternity, carrying the memory of a tiny blue planet through the dark, waiting for an audience that may never arrive. Almost every popular narrative about the final destiny of Voyager 1 ends with the exact same, deeply flawed assumption. If you listen to the standard accounts of deep space exploration, they will tell you that once the spacecraft's nuclear battery finally drains and its radio falls permanently silent, the probe will simply drift in a straight, unchanging line through an empty void forever. They paint a haunting, but fundamentally incomplete picture of a frozen, eternal tombstone, gliding completely untouched through a dark and dead universe until the end of time itself. They treat the vacuum of interstellar space as a static museum, a completely empty canvas where human artifacts simply wait in the dark to slowly rot away from microscopic dust impacts. But this widely accepted vision of Voyager's ultimate fate, the idea of the eternal drifter, completely ignores the violent, living reality of the cosmos. Space is not a static environment, and the Milky Way is not a frozen tomb. It is a massive, dynamic, churning ecosystem of stellar death, chaotic gravity, and violent rebirth. And the most crucial fact that these standard narratives miss is that Voyager is not flying in a straight line. To understand the true, mind-bending fate of humanity's greatest machine, we first have to shatter the popular illusion of its escape. You have likely seen the global headlines celebrating Voyager's departure from the solar system, leading many to incorrectly assume that it will eventually leave our galaxy altogether and sail out into the great intergalactic void. This is a physical impossibility. To escape the immense gravitational well of the Milky Way, an object would need to travel at a staggering escape velocity of roughly 600 kilometers every single second. Voyager 1 is currently traveling at a mere 17 kilometers per second. Even when you factor in the rotational speed of the galaxy itself, which adds to its momentum, the spacecraft is moving nowhere near fast enough to break free from the Milky Way's unimaginably deep gravitational pull. It is not escaping. It is permanently trapped inside our galactic disk, bound by the exact same immense forces that hold hundreds of billions of stars, gas clouds, and dark matter halos together. Because it is gravitationally trapped, Voyager is forced to orbit the supermassive center of the galaxy, a journey that takes roughly 225 to 250 million years just to complete a single revolution. But a galactic orbit is not a neat, perfect circle drawn with a cosmic compass. It is an incredibly chaotic, looping path through a constantly shifting landscape. The stars around it do not remain fixed on a distant ceiling. They are all racing around the galaxy in different directions, at different speeds, and at varying inclinations, creating a deeply turbulent gravitational environment. Over hundreds of millions and billions of years, Voyager will be subjected to the combined, pulling forces of passing stars, the immense tidal shifting of the galaxy itself, and the invisible but overwhelming mass of dark matter. Every single time Voyager passes within the wider neighborhood of another star, that star's gravity tugs at the tiny 1.5-ton metal probe. Most of these pulls are incredibly weak, barely registering as a fraction of a degree of influence. But over a timeline of billions of years, these chaotic gravitational perturbations exponentially accumulate. A close pass by a red dwarf, the distant pull of a wandering black hole, or the subtle but relentless drag of the galactic tide all act as unplanned, natural gravity assists. They will slowly bend, twist, and radically reshape the spacecraft's trajectory. The straight line is a human illusion, born from our inability to comprehend deep time. In reality, Voyager is a microscopic piece of driftwood caught in the incredibly complex, swirling gravitational currents of a massive cosmic ocean. This chaotic celestial dance is exactly where the standard narrative of the frozen, eternal drifter falls completely apart. Over these unimaginably vast timescales, these chaotic gravitational nudges possess the mathematical power to pull Voyager away from the sparse, empty regions of the interstellar medium and steer it directly towards something far more profound. The Milky Way is not just empty space. It is filled with vast, swirling structures known as giant molecular clouds. These are colossal stellar nurseries, dense, cold regions of space packed with ancient hydrogen gas, frozen carbon monoxide, and interstellar dust. They are the immense crucibles where gravity gathers raw material together over millions of years until the internal pressure becomes so intense that brand new stars violently ignite. According to an exclusive, highly debated concept found deep within the lore vault known as the galactic recycling hypothesis, Voyager's journey may not end in eternal, silent isolation at all. Instead, the chaotic gravitational currents of the Milky Way could eventually drag the dead spacecraft directly into the heart of one of these dense, star-forming molecular clouds. This is the massive lore gap that competitor theories completely ignore. If Voyager's perturbed orbit carries it into one of these stellar nurseries, the environment around the probe will undergo a terrifying and magnificent transformation. The near-perfect vacuum of empty space that protected its metal chassis from decay for billions of years will slowly be replaced by thickening gas, rising friction, and the swarming, chaotic dust of a collapsing nebula. As Voyager plunges deeper into the molecular cloud, it will no longer be a passive drifter. It will be caught in the overwhelming gravitational collapse of a newly forming stellar system. The massive cloud around it will begin to violently compress under its own immense gravitational weight, spinning faster and faster as it flattens into a monstrous, superheated accretion disk. At the very center of this spinning vortex of gas and dust, The intense pressure will trigger nuclear fusion, and a brand new protostar will begin to furiously burn. Voyager, carrying the absolute final evidence of humanity's existence, will be pulled inexorably into this swirling primordial storm of cosmic creation. For billions of years, the biting cold of absolute zero was Voyager's greatest preserver. It prevented rust, stopped corrosion, and froze its 1970s circuitry into a state of near-perfect geological suspension. But inside the violent accretion disk of a newborn star, those protective conditions will be utterly annihilated. The temperatures and pressures will rise to unimaginable extremes. The patient, microscopic sandblasting of deep space that barely scratched its surface over millions of years will be violently replaced by the raw, melting heat of stellar ignition. The long, silent journey of humanity's greatest machine will finally reach its physical, catastrophic end. As it spirals deeper into the superheated disk, the solid aluminum chassis that endured the absolute emptiness of the void will begin to warp, buckle, and melt. The complex vintage circuitry, the decayed inert spheres of plutonium-238 that once powered its heartbeat, and the woven fiberglass of its high-gain antenna will be completely incinerated. The intense cosmic forces will break the spacecraft down at a molecular level, reducing the 1.5-ton monument of human engineering to a glowing stream of raw atomic matter. But the most profound and philosophically devastating destruction will happen to the Golden Record. For billions of years, this 12-inch, gold-plated copper disc was treated as humanity's sacred time capsule. It held the encoded sounds of earthly thunder, the haunting songs of humpback whales, the electrical brainwaves of a woman in love, and the spoken greetings of 55 long-dead human languages. It was specifically engineered to outlive the Earth itself, waiting patiently in the dark for an alien mind to intercept it, decode its grooves, and remember us. Yet, inside the massive crucible of the molecular cloud, the Golden Record will not be discovered by an advanced civilization. It will be dismantled by the universe itself. The protective aluminum cover will vaporize, the pure gold plating will melt, the copper disc will liquefy, and the microscopic grooves containing the brilliant mathematics of Bach and Beethoven will be permanently, irreversibly erased. The message will dissolve back into the fundamental chemistry of the cosmos. However, the destruction of the physical probe is not the end of the story. In the strict laws of physics, matter is never truly destroyed. It is merely transformed. The individual atoms that once made up Voyager 1 will not vanish from reality. The copper from its communications dish, the gold from its record, the aluminum from its structural frame, and the carbon from its plastic insulation were all originally forged in the furious hearts of ancient dying stars billions of years before the Earth was even born. Millions of years ago, human hands pulled those ancient elements from the dirt of our planet, refined them in blast furnaces, shaped them into a machine of exploration, and hurled them into the infinite dark. Now, inside the violently churning accretion disk of a new star, those exact same atoms will be returned to the great cosmic forge. As the newly ignited star continues to burn, the swirling disk of superheated material surrounding it will begin to slowly cool and clump together. Microscopic grains of dust will constantly collide and stick to one another, forming larger and larger rocky fragments. The vaporized atoms of Voyager 1, now completely separated from their human-made forms, will be swept up in this chaotic, beautiful dance of planetary formation. The molecules of our spacecraft will physically and chemically bond with interstellar ice, alien silicates, and stellar ash from long-dead supernovas. Slowly, over millions of years of relentless collisions, these clumps of matter will grow into massive planetesimals. They will crash into one another with world-shattering force, fusing together under their own newly formed gravity to create the molten cores of brand-new rocky planets. Through this mind-bending cosmological process, humanity's message in a bottle is fundamentally and completely recycled. It does not simply disappear. It becomes the literal building blocks of a new solar system. The gold that once held the analog sound of a human heartbeat might cool and crystallize into a glittering vein of ore buried deep beneath the thick crust of a newly formed exoplanet. The aluminum that formed the chassis of our greatest explorer could be woven directly into the shifting tectonic plates of an alien super-Earth. The carbon, nitrogen, and complex polymers from the spacecraft's internal wiring could eventually outgas from the violent eruptions of alien volcanoes, helping to form the primordial atmosphere of a world we will never see. Through the chaotic mechanics of the galaxy, Earth's history, its actual physical substance, will be literally recycled into alien soil. This exclusive, highly theoretical reality completely shatters the tragic narrative that Voyager is doomed to an eternity of purposeless drifting. The idea of the eternal tombstone suggests a universe of finality, a dark and depressing cosmos where human artifacts simply wait in the absolute cold to rot away into nothingness. But the galactic recycling hypothesis reveals a cosmos defined by endless, beautiful renewal. It reframes Voyager not as a dead, pathetic relic fading into obscurity, but as a metallic seed planted in the incredibly fertile soil of the Milky Way. To follow Voyager into the extreme far future is to completely abandon everything we consider permanent and familiar about the night sky. We are living in a period of cosmic history known as the Stelliferous Era, a vibrant, luminous epoch defined by the continuous birth, brilliant life, and explosive death of stars. Right now, the universe is a sprawling engine of light and energy, with vast clouds of molecular gas constantly collapsing under gravity to ignite brand new suns. But this era of light is not eternal, and the cosmic engine is slowly running out of fuel. To truly comprehend the ultimate fate of humanity's farthest emissary, we must push our timeline forward, not by millions or billions of years, but by trillions of years. We must track Voyager's silent glide through an aging cosmos that is slowly, irreversibly shutting down. As Voyager drifts through the newly formed Milkomeda galaxy, the violent starbursts ignited by the collision of the Milky Way and Andromeda will eventually subside. The explosive birth of massive, brilliant blue giant stars will become an increasingly rare event. These massive stars are the brightest beacons in the universe, but they are incredibly greedy, burning through their nuclear fuel in a matter of mere millions of years before destroying themselves in spectacular supernova explosions. Over billions of years, the sprawling interstellar clouds of hydrogen gas that serve as the fundamental raw material for star formation will be gradually depleted, consumed, or blown apart by stellar winds. As the universe ages 10 billion years and beyond, the rate of star birth across the cosmos will violently plummet. Voyager will find itself drifting through a fundamentally altered galaxy, one that is undergoing a massive cosmological shift. As the bright, massive stars die out and are not replaced, the overall light of the stellar populations around the spacecraft will begin to drastically redden. The galaxy will become overwhelmingly dominated by red dwarf stars, like the star Gliese 445 that Voyager will have passed tens of thousands of years prior. Red dwarfs are small, dim, and incredibly conservative with their fuel, slowly fusing hydrogen at a measured pace that allows them to endure for hundreds of billions or even trillions of years. They are the ultimate survivors of the Stelliferous Era. As Voyager sails through the deep future, these faint crimson embers will be its primary companions, casting a ghostly, fading glow across the probe's sand-blasted aluminum frame. But even the resilient red dwarfs are not immune to the unforgiving march of entropy. Trillions of years from now, the very last of these dim stars will finally exhaust their remaining hydrogen. They will not explode. They will simply shrink and fade, joining the countless billions of other dead stars in the cosmic graveyard. The universe will formally exit the Stelliferous Era and cross the threshold into what astrophysicists call the degenerate era. In this unimaginably distant epoch, the cosmos will go entirely dark. In the degenerate era, the universe will be populated almost exclusively by dead stellar remnants, white dwarfs, neutron stars, and black holes. The white dwarfs, incredibly dense embers roughly the size of the Earth, will glow faintly with leftover thermal energy for trillions of years, supported against total collapse only by the bizarre quantum mechanical resistance of electron degeneracy pressure. Voyager will drift through a terrifyingly dark and silent expanse, passing these cooling stellar corpses as they slowly radiate their last remaining heat into the expanding void. As the white dwarfs eventually cool entirely, they will become black dwarfs, invisible spheres of ultra-dense carbon and oxygen drifting unseen in the pitch black. The only remaining sources of significant gravity will be the black holes, ancient and invisible predators waiting silently in the dark. And yet, even in this dying, blackened universe, Voyager will persist. Its structural survival defies almost all human comprehension. The near-perfect vacuum of space will have protected it from the rapid decay that erases human monuments on Earth. Without an atmosphere to cause corrosion, and without the violent tectonic forces of a living planet, its metal skeleton will simply endure. It may suffer the excruciatingly slow erosion of microscopic dust impacts, pitting its surface grain by grain over quadrillions of years, but because the degenerate era is so unfathomably empty, the chances of a catastrophic collision will remain statistically negligible. The distances between the dead remnants of stars will be stretched to incomprehensible extremes by the relentless expansion of the universe, ensuring that Voyager will continue its ballistic trajectory completely undisturbed. As the universe plunges into absolute darkness, Voyager will undergo its final and most profound transformation. It will cease to be just a spacecraft, and it will become the ultimate Dark Era artifact. It will drift through an endless sea of dead black dwarfs and black holes as a ghostly physical remnant of a luminous, vibrant universe that no longer exists. It will be an anomaly of matter, a uniquely structured object carrying the undeniable signature of intelligence, floating perfectly preserved in a cosmos that has entirely forgotten what life is. Bolted securely to its side, the golden record will serve as the crowning paradox of this dead universe. Protected by its sacrificial aluminum cover, the gold-plated copper disc is highly likely to survive physically intact long after the last star has burned out. Encoded within its microscopic, analog grooves are the sounds of thunder rolling across a primordial sky, the haunting songs of humpback whales echoing through vast, liquid oceans, and the raw, rhythmic energy of human music. It carries the spoken greetings of 55 long-dead languages and the electrical brainwaves of a young woman experiencing the profound, overwhelming emotion of falling in love. Imagine the sheer philosophical weight of that object existing in the degenerate era. The universe around Voyager will be defined strictly by the cold, mechanical laws of gravity and entropy. It will be a realm of absolute zero, devoid of warmth, devoid of light, and fundamentally incapable of supporting any biological chemistry. Yet, slicing through that terrifying silent void at tens of thousands of miles per hour will be a piece of metal vibrating with the memory of a warm, wet, and incredibly chaotic planet. The golden record will stubbornly hold on to the concept of light, the geometry of the human body, and the sound of rainfall, carrying the ghost of a blue world into a future where the very building blocks of oceans and atmospheres have been locked away in dead stellar cores. In this dark era, the true tragedy and the ultimate beauty of Voyager's mission become indistinguishable. It was constructed by a brief, fleeting species that dared to look up at the infinite and decided to shout into the dark. The creators of Voyager knew that their world would not last forever. They understood that in 5 billion years, their own sun would swell into a monstrous red giant, incinerating the Earth and vaporizing every single trace of human history, every monument, and every memory. They built the golden record precisely because they refused to accept total erasure. They crafted a message in a bottle specifically to survive the death of their world, but they inadvertently built something that will survive the death of the stars themselves. Voyager's existence in the late stelliferous and degenerate eras forces us to confront the deepest mystery of all. What is the meaning of a message if there is absolutely no one left to read it? In a universe populated entirely by black holes and cold, dead matter, the concept of a recipient for the golden record becomes entirely abstract. The map to our solar system etched onto its cover points to a sun that has long since faded into a dark, undetectable ember. The civilization that encoded the message has been entirely swept away by the merciless currents of deep time. The bottle is simply drifting on an endless black ocean, holding a love letter from a ghost. But perhaps the necessity of an audience was always an illusion. Voyager does not need to be found to be profoundly successful. Its victory lies not in arriving, but simply in continuing. As the universe stretches out and the lights of the cosmos are extinguished one by one, Voyager's relentless forward momentum becomes a defiant, eternal act of rebellion against the encroaching dark. It is a monument to the fact that for one incredibly brief, brilliant moment in the history of a 13.8 billion-year-old universe, matter managed to wake up, look at the stars, and build a machine to reach them. Trillions of years from now, when the cosmos is nothing but an unrecognizable wasteland of dead remnants, Voyager 1 will still be out there. It will not care that the Milky Way is gone. It will not care that the universe has gone dark. It will simply keep going. It will endure as the ultimate cosmic tombstone, an eternal drifter carved in pure velocity. It proves that humanity, a fragile species bound to a dying rock, had the absolute audacity to write their memories onto a piece of gold and cast it into eternity. It is the ultimate proof that we existed, we mattered, and we refused to go quietly into the night. And as it sails forever through the dead, black universe, carrying the faint, frozen echoes of human love and earthly oceans, Voyager will remain the most beautiful, terrifying, and enduring thing our species will. Up until this point, we have traced Voyager's journey strictly through the cold, unforgiving lens of classical astrophysics. We have watched it outlive the Earth, drift completely unscathed through the violent gravitational merger of two colossal galaxies, and mathematically outlast the fiery death of its own creator star. We have treated the universe as a purely physical landscape, governed entirely by the absolute laws of gravity, momentum, and thermodynamics. But to truly grasp the absolute limits of this journey, we must now take a massive, terrifying leap beyond the boundaries of astrophysics and plunge directly into metaphysics. We must look at a theory hidden deep within the most obscure corners of speculative science, a concept so mind-bending that it forces us to question the very fabric of reality itself. We must ask a question that seems simple on the surface, but hides a deeply unsettling paradox. Why did human beings, a species entirely obsessed with destinations, build a machine that goes absolutely nowhere, forever? Think about the fundamental nature of human engineering. Every vehicle, every vessel, and every machine humanity has ever constructed was built to arrive. We build ships to reach a distant harbor across the ocean. We build airplanes to land at a specific runway. Even our most ambitious space probes, the rovers crawling across the red dust of Mars or the brilliant orbiters that map the rings of Saturn, were designed to arrive at a highly specific coordinate, study it, and eventually die there. Human engineering is inherently defined by the concept of a finish line. But Voyager fundamentally breaks this rule. It does not have a destination, and there is no hidden mechanism drawing it toward a special terminus out in the void. Its trajectory is an open-ended line carved into the vacuum, a path that will never naturally conclude. It is a machine of pure, unadulterated velocity, continuing endlessly through space long after everything that made it has vanished into entropy. If you look at this through the lens of pure biological logic, it is an absurdity. Why would a logical, resource-constrained species on a tiny blue rock throw a piece of themselves into the infinite, knowing full well it will never arrive anywhere? To answer this, we turn to a profound metaphysical shift in the narrative known as the simulation hypothesis. This is not a cheap science fiction trope. It is a serious, rigorously debated philosophical and mathematical proposition which suggests that our universe, with its perfect mathematical laws and quantum unpredictability, might not be base reality at all. Instead, it proposes that everything we experience, from the warmth of the sun on your skin to the immense, swirling gravitational pull of the Milky Way galaxy, is actually an unfathomably complex digital simulation generated by a higher, post-human intelligence. In this scenario, the laws of physics are merely lines of code. Gravity is an algorithm, and the vast, terrifyingly empty distances between the stars are essentially massive, rendered backgrounds designed to keep the simulated inhabitants, us, isolated within our local, planetary sandbox. If we accept the chilling possibility that our reality is an artificial construct, the story of Voyager undergoes a massive, terrifying transformation. It ceases to be a simple scientific instrument exploring the outer planets. Instead, according to an exclusive, highly speculative theory, Voyager's infinitely expanding trajectory acts as a long-term pointer or experiment within this simulated universe. To understand this, we have to borrow a concept from computer science. In programming, a pointer is a specific type of variable. It does not hold a traditional value like a number or a word. Instead, it stores the exact memory address of another location within the system's architecture. It is a directional arrow, telling the computer where to look in the vast, underlying grid of memory. By hurling a physical object into the deep, unending void of interstellar space, humanity subconsciously created a rogue cosmic pointer. We fired a bullet out of the carefully rendered simulation of our solar system and aimed it directly at the absolute limits of the simulation's processing power. Consider how modern virtual environments operate. To save immense amounts of processing power, a digital engine does not render the entire universe at once in perfect, high-resolution detail. It only generates the specific environment that the observer is currently interacting with. The mountains in the far distance do not truly exist as complex physical geometry until the observer walks toward them. If our universe is a simulation, it likely operates on a highly advanced version of this exact computational efficiency. The unimaginably vast, dark ocean of the interstellar medium, where a single cubic centimeter of space holds only a tiny handful of atoms, does not need to be fully rendered because no one from Earth has ever been there to observe it. But Voyager changes the rules of the entire system. Voyager is an active physical observer. It is a data-gathering object occupying space, traveling at 38,000 miles per hour into regions of the code that were entirely empty. As Voyager drifts outward, crossing the termination shock and piercing the heliopause, it essentially forces the simulation's engine to constantly generate and render new, increasingly sparse regions of deep space. It stretches the artificial architecture of reality by demanding that the simulation account for its physical presence, its gravitational interactions with passing dust grains, and its trajectory through the void. It is forcing the cosmic computer to constantly expand its active memory map. This entirely reframes the purpose of the Golden Record. When the visionary minds of the 1970s bolted that 12-inch gold-plated copper disc to the side of the spacecraft, they assumed they were writing a message to biological extraterrestrial civilizations. They believed they were throwing a cosmic message in a bottle into a physical ocean. But if the simulation hypothesis is the true nature of our reality, the intended audience of the Golden Record is not alien life. The true audience is the architect of the simulation itself. By designing an analog record, humanity essentially created a highly compressed backup file of our entire civilization. We took the sounds of earthly thunder, the complex mathematical structure of Bach, the spoken greetings of 55 long-dead human languages, and the raw electrical brainwaves of a woman in love, and we etched them into a durable physical medium. We bypassed digital storage entirely, creating an artifact that resists the digital decay of the simulation. We sent a physical zip file of human consciousness and biology directly into the server's deep storage. We are forcing the operating system of the universe to maintain the exact memory of our existence, carrying the physical consequence of a vanished age, long after the primary simulation runs its course, and our home world is inevitably deleted by the expansion of a dying sun. But the true, paralyzing philosophical weight of this theory hits when you push the timeline forward trillions upon trillions of years into an era of cosmology known as the degenerate era. Current models of the universe suggest that cosmic expansion will continue indefinitely, stretching the fabric of space so far that star formation permanently ceases. The beautiful, glowing spiral arms of the Milky Way and Andromeda will entirely dissolve. The universe will be utterly transformed into a dark, freezing graveyard populated only by dead stellar remnants, rapidly cooling white dwarfs, incredibly dense neutron stars, and the silent, invisible maws of black holes. Eventually, over timescales so vast and punishing that they completely break the human mind's ability to comprehend them, even these extreme physical objects will begin to decay. The white dwarfs will cool into pitch-black chunks of degenerate matter. The black holes will slowly evaporate through Hawking radiation, bleeding their mass back into the void particle by tiny particle, until absolutely nothing remains. The simulation, having run out of usable active energy, should theoretically power down, crashing into a state of absolute, featureless zero. It is the ultimate end of the program. But Voyager challenges this absolute finality. As an inert, frozen relic hurtling through the vacuum, it requires absolutely no active energy to continue its journey. The supreme law of inertia dictates that a body in motion stays in motion unless acted upon by an outside force. In a dead, empty universe where all the stars have burned out and all the black holes have evaporated, there are simply no outside forces left to stop it. Thus, mathematically, Voyager outlasts the physical structures of the cosmos itself. It survives the stars. It survives the galaxies. It survives the very concept of light, heat, and gravity. When you observe an object that outlasts the fundamental architecture of the universe it was born into, you are forced to brutally question the fundamental nature of reality. How can a simple 1.5-ton machine built from refined earth aluminum and primitive 1970s circuitry outlive the entire lifespan of 1 trillion galaxies? How can a piece of metal outlast the universe? In the context of a simulated reality, Voyager becomes the ultimate, unresolvable glitch. It is a rogue line of code that entirely refuses to terminate. It is an infinite loop of momentum traveling through a reality that has otherwise entirely shut down. The simulation was designed to model the birth, life, and eventual heat death of a universe, but it did not account for a tiny, self-obsessed species building an eternal, physical pointer and firing it into the blank space outside the margins. Because Voyager is traveling through an absolute vacuum, experiencing no friction and no decay, there is no mathematical parameter within the simulation's physics engine that tells it to stop. It forces the simulation to remain active, keeping a fractional percentage of its processing power perpetually dedicated to tracking the location of a single, silent, golden disk drifting through an infinite void. This deeply speculative metaphysical angle changes absolutely everything we feel about Voyager. It completely strips away the warm, comforting romanticism of the interstellar handshake and replaces it with a profound, terrifying awe. We did not just build a scientific tool to take pictures of Jupiter and Saturn. We built an immortal paradox. We constructed a physical object that proves humanity had the audacity to throw a wrench into the very machinery of existence. If we are living inside a massive cosmic computer, Voyager is our ultimate virus. It is an infinitely expanding pointer variable that simply continues, endless and unbothered, proving that even a simulated species can generate an outcome that fundamentally defies the parameters of its own programming. The spacecraft forces viewers to recognize that our ultimate legacy is not what we built on Earth, but the fact that we managed to infect the universe with an object of perfect, unstoppable continuity. The story of Voyager is not about exploring the Milky Way, and it is certainly not about finding alien life. It is about humanity's subconscious, desperate desire to break out of the map. It is about our drive to sail past the rendered horizons of our reality, to force the hands of our unseen creators, and to drift eternally into the unwritten, empty code of the absolute unknown.